All right. So let's mess around with Desmos a little bit. What I want to do is we're going to try to explore. Is that it? Yeah. We're going to try to explore how we're going to take a graph and translate it around on the plane. Our goal here, this unit 2, is about transformation. So we're going to be able to take a function, like let's just say we're going to take the function f of x equals the square root of x. So there's what its graph looks like. Okay. What I want you to be able to do here I'm going to freeze this for just a second. I want us to get to a point where we can do stuff like this. Okay, where we could do something like this, where we could say, given this parent graph, square root of x, we could tweak or transform that parent graph to produce a different graph that has some of the same characteristics but looks totally different, right? One of the things that I think sometimes happens in Algebra 2 class that I think is a source of some confusion is that when we talk about graphs, because graphing functions is a big part of what we do, but a lot of times we tend to break that up into, we're going to talk about absolute value functions, then we'll talk about the graphs of absolute value functions. Then later on we talk about quadratic functions, and then we talk about the graphs of quadratic functions, as though they're totally different things, as though the graph of a function is something that's unique to that function, but it's not. What I want you to see instead is that no matter what the parent graph starts off looking like, it could be a square root, it could be an x squared, it could be a parabola, we'll look at one of those today, it could be an exponential function, it doesn't matter. If you know what the parent graph is, you can make a prediction about what we did to change it from the red graph to the black graph, regardless of what the parent function is. Okay, now that's where we're going with this. So eventually, by the end of in about a week and a half or so, you're all going to be able to tell me that, okay, what we did here was that. We took the original function, we subtracted 2 from x, we multiplied the function by -3, and then we added 4. And that's what caused the black graph to happen based on the red graph. Okay, that's down the road a little bit. For today, we're not going to be so elaborate. For today, we're just going to do something a little bit easier. I want to we're just going to try to slide these things, okay? So I'm going to start off with just plain old g of x equals f of x. So these two, oh, that's the wrong color. I've got to do a different color. How do I do that?
I think because you have it equal to f of x.
No, it's not. Oh, there we go. Make it blue. There we go. I just cycled through the color. Anyway, so now you see that the blue graph is just right on top of the red graph because g of x equals f of x. Okay, but what we want to do with this, I challenge you here. I want you to figure out what I could do to f of x to take the blue graph, and let's say we want to move it up by 3. What would I do? Any suggestions?
Plus.
If your desk pointing backwards, let's go flip it around so you're facing forward. I mean, at least you got to be facing forward. I don't care. What do you think? Yes, sir.
Would you just add 3?
Add 3 to what?
F of x?
Okay, add 3 to the whole thing, to f of x. Let's see what that does. So if I just add 3, sure enough, look what it does. Okay? Doesn't that make sense, right? Think about what a function does. If I wanted, for example, let's just go over to the red graph for a moment. I'm going to turn this off. And for the red graph, what's going to happen if I evaluate the red graph at 4? So I want to do f of 4, meaning I'm going to put in an input value of 4. What would the output be?
Radical 4.
What is radical 4? What's the square root of 4?
2.
2, right? Does that make sense? So if I'm going to put a value of 4 in for x, I'm going to get back a value of 2. And we can see that's the point right there, can't we? Right? Okay. Another way of looking at that, just to show this is all consistent, we could take the vertical line x equals 4 and intersect it with the red graph, and what do you know? The coordinates are 4, 2. Well, we can see those same coordinates right here, right? We're inputting 4, and then down here it says equals 2, so we're outputting 2, right? That make sense? Okay. So the value of the function is giving us back the y value for any input, right? We input an x, and f of x gives us back a corresponding y value. So then what's going to happen if we take the output of any function and add 3 to it? We're just adding 3 to all of the y values. Everybody see that? So when we do something like this, if we take, let's go back to this g of x here. If we take the original function and we add 3, then every point that's on the red graph has now been, like this point right here, for example. This point has just been shifted up by 3. So has this point right there, right? That used to be over 9 and up 3. Now it's over 9 and up 6, right? In each case, every y value's just been shifted by 3. So what's that look like in terms of just a general thing then? What can we say in general about functions? So if we're starting with some parent graph, so that's going to be just the most basic version of a function we can get. If we start with some parent graph, f of x, or some parent function, and we want to create a new function that goes, shifts horizontally, vertically, not horizontally. That shifts vertically by some amount, let's call it k. That's what we always call it for some reason. It's going to shift it vertically by k. Then we could say that g of x is equal to my original parent graph plus k. So whatever the number is for k, that's telling us the vertical shift, right? So what if, let's go back to our graph then. What if I want to, instead of going up by 3, what if I want to go down by 2? What would I do? So I'll call this h of x. And it's going to equal f of x plus negative 1. Well, look what we did, right? So k has a value of negative 1, so everything, all the y values were shrunk by 1, right? And plus negative 1, an easier way to say that is just minus 1, right? Okay, no big deal, right? Okay, let's look, just for a second here, let's look at what those questions on the assignment are going to be like. Make sure that these make sense to you. Whoops, so if we go into here, like something like this problem. Okay, what's this saying here? Oh, by the way, I tried to, for each of these sections, like the vertical translations and the horizontal, and the one where it's doing both of them at the same time, I tried to give you some information that's helpful. For each page, you'll get a little reminder about what's going on. Well, this is what we just said, right? F of x, if g of x equals f of x plus k, k is the number added to the function, k is the vertical shift, right? So what about this first problem here? We're given this graph, that's our parent function, f of x, and we want to choose the blue graph that does this, f of x plus 4. Well, which one is it? First one, right? Because all I did was I just added 4 to y, so I shifted it up by 4, right? Okay, no big deal. Let's go to another one. What about something like this guy? Okay, what if you wanted to, this time, you're going to write the rule for the function g of x if that translates f of x down by 14. So what's that going to be? G of x is going to, in terms of f of x, how am I going to tweak f of x? F of x minus 14. Okay, you get the idea? Not a big deal. Okay, so far so good. So far so good. Okay, let's go back to our graph. Now we're going to try something different. Now this time, let's take our parent graph, and instead of translating it vertically, we want to translate it horizontally. What am I going to do? Throw out some suggestions. So I'm going to make a new function, g of x. Okay, right now it's the same thing as f of x. How am I going to tweak f of x to make the purple graph slide horizontally instead of vertically? What's the suggestion?
X minus 4 plus 5.
Okay, so x, like in there, I'm going to do, okay, so x minus 4, let's say. Look what it did. What did it do? Moved it horizontally. Moved it horizontally by 4. Now, what if I want to make it go to the left? Okay, I add 4. Okay, that's a little strange though. The vertical shift was really simple, wasn't it? Because if you want to go up by 7, you add 7. That makes sense. That's the positive vertical direction. So to go in the positive direction, we add positive 7. This seems to be a little bit backwards, doesn't it? Right? If I want to go to the right, I'm subtracting 4. That's a little strange. Okay, let's think about why that might be the case. So let's try this. Let's say we're going to do, let's change the graph a little bit. Let's do f of x equals x squared. Okay, so there's my new parent graph, f of x equals x squared. We all know what this looks like, right? This is a parabola. What's the behavior of this parabola? If I go over, so if I'm going to input a value of 1, what do I get back for y?
1.
Yeah, I go over 1 and up 1, right? Input 1, output 1. Okay. What if I input 2?
4.
Yeah, let's make sure, I should see all those Chromebooks should be closed, please. If I go over 2, I'm going to go up 4. I input 2, 2 squared is 4. If I input 3, I get 9, right? And if I go back the other way, because I'm squaring it, a negative number squared is positive. So does it make sense that if I go negative 1, I still go up by 1? I go negative 2, I still go up by 4, etc., right? So we're familiar with that. You probably haven't worked with that in a long time, but you've worked with that kind of thing before. Okay, so let's just fill out this little table, and this is going to help things a little bit. So we're defining our parent function as f of x equals x squared. We're going to tweak that with g of x is going to be a tweaked version or a transformed version of f of x. And we're going to subtract 2. So what's that going to do again? Okay, that's going to move to the right by 2, isn't it? Okay, so we know that doing this is going to move it right by 2. Let's think about why that would be. Let's just pick some input values here for x. So what if we were to, for example, let's pick the input value negative 2. If x is negative 2, what's the output of f of x going to be? 4, right? So we get the ordered pair, negative 2, 4, as we saw. Okay, but what about g of x? So think what a function does, right? A function, if we think of it like a machine, we feed it input values, and it's going to, the bells and whistles are going to whir, and it's going to do its thing. It's going to spit out an output value, right? This function, all it's doing is squaring the input, right? But what happens if we trade the x for an x minus 2? It's like we're tricking the function in a way, because look what happens. If I input an x value of negative 2, but then I'm subtracting 2 from x, what's the value of x minus 2?
Negative 4.
Negative 4, okay? And then what happens when I square that input? What do I get back? No, not negative. I get back positive 16. Okay, let's just work down the list a little bit, and you're going to see the pattern emerge. And this will this should explain why this thing behaves so strange, why we're subtracting a number to make it go in the positive direction. So let's try negative 1. What's the output of this one? Negative 1 squared is 1. Okay, if I'm going to go ahead and subtract 2 from my input value,
Negative 1.
Negative 1 minus 2 is
-3.
negative 3. Thank you. Let's see. Here, here. Perfect. Thanks. Why not? Don't pass that back. Whoops. Okay, so if I subtract 2 from negative 1, that's going to give me a negative 3. If I square negative 3, I'm squaring the number, the input number.
9.
I get 9. Okay? 0. When x is 0, the output of the function 0 squared is 0, but g of x is seeing an input value of negative 2,
It's 4.
squared is 4, right? What about 1? Input an x value of 1, 1 squared is 1, 1 minus 2 is
Negative 1.
negative 1, squared is 1. Plug in 2, I get 4, here I get 0, here I get 0, right? Let's go down just a little bit. A couple more, we're done. Input 3, I get out 3 squared, which is 9 from f of x. But when I subtract 2 from that input, I get 1, 1 squared is 1. Last one, if I input 4, I get 16. 4 minus 2 is 2. 2 squared is 4. Okay, well, look at something here. Here's 1 point. There's the vertex of my parabola, right? If we were to go back to the graph, that's right there, isn't it?
Yeah.
Right? That's the point 0, 0. Where's the vertex of g of x? That's when y is 0, right?
2, 4 is on.
2, 4.
So that's right here. Yeah, it's at 2, 0, right? See what I'm saying? Here's where I'm inputting. You see that? I'm inputting a value of 2, and I'm getting back a value of 0. Well, what did that do? Predictably, that means that it's just gone over to the right by 2. Right? You told me that was going to happen. All the points were getting shifted to the right. Why did it happen? Well, we tricked the function, right? By subtracting 2 from the input, think about the numbers that we end up actually feeding the x squared function, right? When we're feeding in a value of 2, for example, when x equals 2, when we subtract 2 away from x, that gives us back 0. The number that's being fed to f of x then, to x squared, instead of being a 2, it's a 0, right? You see what I'm saying? So when we normally would think we're giving this, the function thinks it's at x equals 0 because it's getting a value of 0, which squared is 0. It thinks it's at the vertex, right? But what x value did we actually input to feed g of x? A 0, a 2, right? Doesn't that make sense in terms of the graph then? If we look at the graph, that means that when we input a 2, the x squared graph thinks it's right there, but it's not. It behaves like it's right there because the input value that's being squared is a 0. It's not though. It's actually a 2. So what's the effect of that? Well, the point that's the vertex of the parabola, the one that gives us an output of 0 for an input of 0, is actually happening when x is 2, right? So we tricked it. We tricked it into thinking it's there, but it's actually there, right? Okay, so the moral of the story then is, what can we always say about a horizontal translation? Okay, we can say something like what we did for a vertical translation, right? If the parent graph is f of x, and if we want to shift vertically, or horizontally, sorry, by an amount which we're going to call h, right? Then we could say that g of x must equal f of x minus h. Okay? So the amount of the horizontal shift is always going to be the number that's being subtracted from the input value x, right? Okay, so we're going to trade an x for an x minus h. So try a couple of those. Let's just look at the assignment. So how about this one then? If the red graph is f of x, that's our parent graph, and the blue graph is going to be f of x plus 6, what have we done?
To the left.
We've moved it to the left. What's the value of h there? What's the value of h? Because h tells us how far we're moving. Not 6. It's negative 6. How come? That's why. Because h is the number that's being subtracted from x. Well, what number is being subtracted from x there? If I have f of x plus 6, that's the same thing as x minus what?
Negative.
Yeah. Subtracting a negative makes a positive, doesn't it? Right? You get that? So the value of h then, this is weird, the value of h, or the sign of h, is always going to be opposite of whatever the symbol between the x and the number is. It's backwards, right? Okay? So this takes us to the left, predictably, so that's our answer. Let's try another one. How about this guy? Oh, let's do a different one. Oh, it's the same one. Let's reload that. Okay, so what's that going to be then? What's g of x? If f of x is the parent graph, what am I doing? Yeah. It's going to be f of, I'm going to trade the x for an x minus negative 4, x plus 4. Everybody see that?
Yeah.
Okay. Okay, what about this? What if you want to do this? What if you want to move a graph to the right by 12 units? You want to move f of x to the right by 12 units. G of x is going to have to be, how am I tweaking f of x? Yeah, good. Good. I'm trading the x for an x minus h. H is positive 12, so it's x minus 12. Okay? Now, what if I do both? What if I want to do this? What if I want to go down 13 and to the right by 4? Okay, here's what I would recommend. Start with the easy one. So let's start with f of x. If I want to go down by 13, that's simple. What do I do? Subtract 13 from the function, right? So outside of everything, I subtract 13. Now let's go back and see what do we want to do to the x? I'm going to trade the x for an x minus h, but what's h going to be? 4, so I got to go x minus my h value, which is 4. Okay? You get the idea?
Yeah.
Okay? Why don't you just work on that? Here's what we have to do. My expectation is this is going to be a homework for you, so you have to go in and try at least one from each section. Okay? At least one from each section, and once you've done that, which probably will take you about 3 minutes, then I don't care what you work on. Yep.
Are we having reading